So yesterday we did cover all the note sheets. We got through all the notes, the main notes that we wanted to cover with that. And make another slide. Because we talked about the area of a triangle. So the area of a triangle is equal to 1/2 the base times the height. And then whenever we look at a triangle, the overall height is going to be the distance from a vertice to the opposite side and forms a right angle, essentially the altitude. Now, if it is a right triangle, well, the base and height are the two legs, the two sides that form the right angle. Height, base. And I mean, if they stick a triangle inside of a square, well, the height is actually going to be the same as the length of the rectangle or square going up. The other one we talked about was a rectangle or square, which is area is length times width or base times height. And sometimes they'll talk about a square's area as s squared, the side length squared, because the side lengths of a square will all be the same. We also talked about a parallelogram, which is area is length times width, or I think they called it base times height. And the last one was a trapezoid. And the area formula for a trapezoid is 1/2 of the times the height. And I mean, there are other area formulas beyond this, and since they got rid of the EOIs, you're not required to actually know all of them. They used to make y'all memorize all of them. But those are the main ones there that we have so far. So we're going to look through some of the example problems. I have 4 that I picked out that I want to do with y'all. We'll do one more that y'all want to, if I'll let y'all pick out of the group, and then I'll have y'all do the exit ticket. Now, the first one I want to look at is number 2 in the note sheet. The dimensions of a right triangle are shown below in feet. What is the area of the triangle in square feet? Well, our area formula, area is equal to 1/2 base times height. So what would the base of this triangle be? And the height, x plus 3. Could I have actually said that the base is x plus 3 and the height is 2x plus 1? Well, yeah, because again, we're just multiplying these together. Well, if we look at the answer choices, because again, we got it set up, and I'm just looking at the answer choices. We have x squared plus 3, x squared plus 9, these two in the middle, and then 6x squared. So what is the first thing we would do with this here? Well, we can multiply these two together, yes? So we would do 2x times x is squared. 2x times 3 is plus 6x. 1 times x is plus x, and 1 times 3 is 3. The next thing we would need to do is combine like terms, yes? At this point, is there any way that the x's, the middle term, is going to cancel out completely or disappear? Well, I still have an x term by the time we get done. Well, yes, because there's no way to get rid of it. The only way that we can get rid of it is if we're subtracting here 6x and x, because we would need 7x subtracted from it to get rid of it. Well, so is there any way that I could end up with x squared plus 3? Because that middle term will still be there, yes? So f is not going to work. D isn't going to work. And K isn't going to work, right? Okay, let's keep working this. So 1/2. So if I combine like terms, I would have 2x squared plus. So most likely it's not j, because the last thing we need to do is multiply it through by. So 1/2 times 2, x to the second power, because 2 times 1/2 is 1, plus 2. That's the only one that matches up with those first two terms, yes? Well, if I finish this out, we would have plus 3/2 x, yes? Did I need to finish that? No. In a lot of the problems, if you do get it down to 1 where you have the answer and you're almost done, don't finish. No need to. There's no need to finish and you already got the answer. Why waste the time finishing it? And a lot of these multiple choice math tests, if you can get to that, that's the best way to do it. All right. Any other questions on 2? Not too bad. 4. I want to look at number 5. A farmer wants to double the area of his rectangular 6x10 garden. The 10-meter length will be increased by 2 meters. How many meters will the width be increased? Well, so we're starting out with a 6x10 garden. Yes? And we're wanting to what? Double the area. So what's the area of the original? Because we'll do 6 times 10, which gives us 60. Okay, so we want a new one, yes? And if we double the area, it was 60, it's going to be what? 120. So the new area is 120, yes? Okay. So 10 is now 12. We want to know what this is, yes? 12. Because we can say 120 divided by 12 because x times 12 is 120 is what we're saying. Divide by 12. So x is 10. So the correct answer is not 10. Exactly. By because we have 6 over 10, because we could say, well, I don't want to write in a highlighter. 6 over 10 is equal to x over 12. And we can multiply both sides by 12, because these would x here, because that would be 60 over 10, so x is equal to 6, which is c, but because it was 6, and we actually needed to go to 10, the actual answer is 4. And the reason is it's not actually increasing by the the proportion amount of increase is not the same. There's a reason that won't work. Because if the amount of increase for the 10 meters to our new length was going to be the same as our 6 meters to the new length, then the proportions would work out. So here, it doesn't work out that well. Yeah, but the correct answer here is 4, because our new one needs to be 12 by 10. The old length was 6, so it needs to increase it by a scale of 4. Any other questions on this one here? 7. In a certain rectangle, the ratio of lengths of two adjacent sides is 4 to 3. If the area of the rectangle is 192 square centimeters, what is the length in centimeters of the longest side? Okay. We can all picture that clearly in our head, yes? Not so much. Let's draw it. So they say two of the adjacent sides of a rectangle. Well, a rectangle's opposite sides are going to be congruent. This is not coming from the fact that it's a rectangle, or I mean just from the definition of a rectangle, but the fact that all rectangles are parallelograms. A parallelogram is any four-sided shape with two sets of opposite sides that are congruent. So the opposite sides are congruent and the opposite angles. Just by the pure definition, a rectangle is a four-sided figure with 4 right angles. So we do have this property true. Now all 4 sides could be congruent, but they're telling us that the ratio is 3 to 4. So for every 3 centimeters one side has, the other side has 4. So it's not saying that this side length is 3 and this side length is 4. It's just some unit of 3, and this is some unit of 4. And if we multiply them together, this ratio, we get 192. Yes? Or do we know how many sets of 3 and how many sets of 4 we have? No? So we could say 3x and. So 3x times 4x is 3 times 4 is squared is 192. Well, here we can. If we square root first, we'd have to square root the 12. So these would cancel, giving us x squared is equal to, because 12 goes into 19 one time, leaving us with 72. Square root both sides, so x is equal to 4. Now, for those of y'all that are still in Algebra 2, and those that had it last year, because again, when we square root both sides, we have the plus or. But here I'm talking about what? Can we have a negative length? No. So we don't include the plus or minus. So 3 times 4 is 12. 4 times 4 is, which one did it want? So the correct answer would be 16. And we could have tried different multiples for this here to get there. So I'm going to erase this here, because we could start out with this here, and then we know it's in the ratio of 3 to 4, yes? Well, if I know that, and we want longer side, yes? So the longer side has to be in multiples of, what is one of these that we know won't work? There's no way we can make 6 as a multiple of 4. So now the rest do work, because 12, if this is 12, let me do it in different colors. This side here would be, because 3 times 4 is 12, so 3 times 3 is. And I can do 9 times 12, which would give us 108 square centimeters. And we want 192. Okay? Then I can go on to the next one. Well, 16, for the proportion, this would be 12, and 12 times 16, as we already found out, is, so it's there. So I can use those side lengths to figure out the proportions. Any questions on this here? I mean, we could have actually, they didn't tell us this, but I mean, if I was given, say, two kind of rectangles, well, let's back up. Given one rectangle and another, and we're told that the side lengths are 2 to 3 and 4 to 9 comparatively, and we want to see how the areas or perimeters scale, or areas, I could just compare the ratios to each other. It's 2 to 3 and 4 to 9. Well, if I multiplied 2 and 4, we would get 8, 9, and 3 is 27. So the areas we could say compare 8 to 27. And no matter how we actually do this, because if it's just 2 to 3, because we could have 2 and 3, or we could have, say, so, well, 4 and 6, 8 and 18. Well, the area for this here, 4 times 8 is 32. 6 times 18, 808. But 32 over 108, because we do have 2, which would be 16 over 54, which is actually 8 over. So it still works out to be the same. No matter how much we scale or shrink it, the scale factor will still be the same. That makes sense? Last one I want to look at about all these here is number 12. And I want to look at this one here because it is a little funky. This section down here is not actually a part of it. It's not a part of the figure. It's just saying that this length here is X. That took me a little while to figure out and see that. I thought it was another extension off of that rectangle. In the figure below, the area of the larger square is 100 square inches, and the area of the smaller square is 64 square inches. What is X? Well, what do we know about squares? All sides are equal, so this length, all these lengths are going to be the same, yes? So if the big square, whole big thing, I would, because I'm going to do a whole bunch of shading here, is 100 square inches. So if it's 100 square inches, what are the length and width of the big one? Because 10 times 10 is? And what are we trying to find? This here, yes? What can X not be greater than? If it's greater than 10, well, it is going to be bigger than this length, yes? So it can't be 18 or 36, yes? What else can it not be? Well, 10, because then it would be actually the whole thing. So we're really stuck with 8 and 2. And Ian, why are you saying it has to be 2?
Because the small square is 64 inches. 8 times 8 is 64.
So it can't be 8, it has to be. In most of the tests, and I've heard this before, I don't know if it's still true because the last time I heard this was when I was in ACT prep, so that's been a while, not as long as some of the other teachers here, but it's still longer than most of y'all have been in this class. They talk about most of these here are able to solve without a calculator. A calculator makes it more helpful, but some of these here, we can get to the answer pretty quickly So 2. Any other questions on this here? We can do one more together, and I'm going to let y'all pick out of the 15 which one y'all want to look at. If there's one in there that y'all want to see worked more than the rest. Why not? I'll do both. Because 14, let's see what it says. In the figure below, BC are on line segment AD. And E and F are on line segment DG. Okay, they have that in the figure. The measurements are given in meters. Both ABFG and BCEF are trapezoids. The area A of a trapezoid is given by area equals 1/2 base 1 plus base 2 times the height, where h is the height, b1 and b2 are the lengths of the parallel sides. What is the area of BCEF in square meters? BCEF in square meters. Well, it'd be 1/2 of base 1, which is plus times now at this point here, you can type this whole thing in the calculator and get the answer. Now, if we do this by hand, 80 plus 120 is 200. Half of 200 is, and 100 times 100 is, so the area is 10,000. So a lot of times, some of these here on the math that look a little more difficult, take a few seconds to read it, see what it's saying, and it'll actually get you to the answer, which this one here was actually quite nice. See here. And number 11, in the standard XY coordinate plane, if a triangle has vertices -1, 3, 2, 3, and 2, -4, then what is its area in square coordinate units? Now, square coordinate units. Did they actually provide us with any units anywhere in this? No. So actually just square coordinate units, because we're in a coordinate plane and we're talking about just units, and because it's area, they have to be square. So that really means nothing to us. It's just talking about, hey, we were actually talking about area. Now, this here, at angle B, this looks to be a right angle of the triangle. Now, like I said yesterday, if it looks to be a right angle, then most likely it's actually going to be a right angle. Now we need the base and height. So we need the distances from here to here. So distance is equal to the square root of x2 minus x1 squared plus y2 minus 1 squared. And this here is just our distance formula. So we can go from A to B, so our x values are 2 minus -1 squared plus 3 minus 3 squared. What's 3 minus 3? That's 0. Negative and negative make a. So we have 3 squared is. Square root of 9 is. So the distance for B is.
So couldn't you just count it over?
Yeah.
Let's go -1, 0, 1, 2.
So the distance from B to our x-intercept is, and x-intercepts down to C is. So the overall distance is. Now, the other distance formula that we have is in a one-dimensional coordinate plane is x2, the absolute value of x2 minus x1. Three minus -4 is 3 plus 4, which is. So the area of this is 1/2 of 7 times 3. Well, 7 times 3 is?
21.
And half of 21 is? 10.5. Well, only one of them is 10.5. Only one of them actually has a fraction. Any other questions on these here?
Hey, they might just look at Tez and say,
All right. So the rest of these are for bonus points. The exit ticket, yes. I just posted the exit ticket. So we have that finished, so exit ticket, go on and get that done. So if you want full credit for the exit ticket, you need to have it done by Friday. Most likely I'll be checking it by Monday, so I'll give you a few days grace period there. If you don't get it turned in by then, you turn it in by a week from Friday for half credit. And after that, it is worth 0. So besides the entrance ticket yesterday and the exit ticket here, these are the only 2 math and science assignments that you actually have still out or missing, because all the rest of them that have been given are now, if they're not turned in, zeros, because we're 2 weeks out from all of it. All right. Also, I think y'all know Miss Ellis is not here today. So tomorrow and this week, so you will be in here, but you will be doing English or reading. She will have stuff assigned to you in Google Classroom to do. Okay?